In October 2024, NASA's Juno spacecraft transmitted data that changed everything we thought we knew about Jupiter. The core, the massive ball of rock and metal that anchors the largest planet in our solar system. It's not solid. It never was. And right now, it's dissolving into the metallic ocean around it. Juno has 1 year left before Jupiter's radiation kills it. 1 year to answer a question that makes no sense. How does a planet lose its core and still exist? But that's not the disturbing part. The disturbing part is what happens if it finishes collapsing. Every image you've seen of Jupiter is makeup covering something impossible. Those clouds, those storms, the famous red spot. They're window dressing on a planet that shouldn't exist where it is. Jupiter is too big, too hot, too far from where it was born. And somehow, for 4 billion years, it's been standing between Earth and the radiation that would strip our atmosphere into space. But we didn't know any of this until we tried to look inside. And when we finally did, we found something that defies the laws of planetary formation. Here's the problem with Jupiter. You can't land on it. You can't drill into it. You can't even fly a probe deep enough to matter before the pressure crushes it. Mars? We drive robots across the surface. Venus? We've dropped landers into the atmosphere. Saturn? We deliberately crashed Cassini through the rings to collect data on the way down. But Jupiter eats spacecraft. In 2003, NASA sent Galileo into Jupiter's atmosphere to avoid contaminating the moons. The probe was designed to withstand 20 times Earth's atmospheric pressure. It survived 8 minutes, not because it hit anything, because the hydrogen around it got so dense, so compressed, that it stopped being gas and started becoming liquid. The spacecraft didn't crash. It drowned in an ocean made of air. So when Juno arrived in 2016, NASA didn't try to go deep. They went for gravity. By measuring how Jupiter's gravity tugged on Juno as it flew past, down to shifts smaller than a human hair, scientists built the first map of what's actually inside the planet. And the map made no sense. The core was there, but it wasn't solid. It wasn't even in one place. Dr. Scott Bolton, Juno's principal investigator, described it like this. We expected a clean boundary, liquid on top, solid core below. What we found was more like cosmic soup. The core isn't collapsing. It never fully formed in the first place. Jupiter has a blurry core, a diluted core, like someone put a normal planet in a blender and hit pulse, and nobody knows why. But the gravity data revealed something else. At the center of Jupiter, 30,000 kilometers below those clouds, pressure does something no laboratory on Earth can recreate. It turns hydrogen into liquid metal. Here's how that works. Hydrogen is the simplest element. 1 proton, 1 electron. Under normal conditions, those electrons stay bound to their atoms. But at the center of Jupiter, the pressure is so extreme that it rips electrons away and lets them flow freely, like water. That's metallic hydrogen, a liquid that conducts electricity. If you could somehow bottle 1 liter of this stuff and bring it to Earth, it would weigh 700 kilograms. And the instant the pressure dropped, it would explode with the force of a small nuclear weapon. Jupiter has an ocean of it, 30,000 kilometers deep, spinning, churning, generating electric currents on a scale we can barely measure. And those currents create Jupiter's magnetic field, a magnetic field 20,000 times stronger than Earth's. Strong enough to trap radiation from deep space in a bubble that stretches millions of kilometers across the solar system. This bubble is called the magnetosphere. Every orbit Juno makes through Jupiter's radiation belt, the electronics degrade a little more. NASA built the spacecraft with radiation shielding thicker than a bank vault. Jupiter's magnetosphere traps so much radiation that being near the planet is like standing inside a particle accelerator. Then there's the surface, if you can call it that. The Great Red Spot. A storm so large it could swallow Earth whole. A hurricane that's been raging since before the United States existed. It's dying. In the 1800s, astronomers measured the red spot at over 40,000 kilometers wide, big enough to fit 3 Earths inside. Today, it's barely 13,000 kilometers across. In 200 years, it's lost 70% of its size, and nobody knows why. The storm isn't slowing down. The winds inside still reach 400 kilometers per hour, but the spot is shrinking, tightening, compressing into something smaller and more violent. One theory, the jet streams that feed the storm are weakening as Jupiter's internal heat output changes. Another theory, the storm is sinking deeper into the atmosphere and we're only seeing the top. But here's what makes it worse. As the red spot dies, new storms appear. In 2019, Juno watched a storm form in real time. It started as a small white oval. 6 weeks later, it was the size of Texas. Winds inside reached 600 kilometers per hour. And then it merged with another storm and became something we've never seen before. On Earth, hurricanes last days. On Jupiter, they're measured in centuries. And when they die, they don't fade. They get replaced by something bigger. Because Jupiter isn't just covered in storms. It's powered by them. Jupiter is a self-heating engine. It generates its own weather, its own lightning, 1,000 times more powerful than anything on Earth. Its own wind systems that never stop because there's no ground to slow them down. And all of that energy, all of that heat, all of those eternal storms, they're driven by the same core that's dissolving right now. We've sent probes, we've measured gravity, we've mapped magnetic fields, we've watched storms rage for centuries and tracked lightning that could power entire cities. And yet Jupiter remains unknowable, a liquid metal ocean 30,000 kilometers deep, spinning in eternal darkness, a blurry core that never solidified, a magnetic shield we can't survive without, a migrant planet that stopped moving at exactly the right moment for exactly the right reasons, and we have no idea why. Maybe that's the point. Some things in the universe aren't meant to be fully understood. They're meant to remind us how small we are, how fragile, how utterly dependent on forces we can't control and barely comprehend. Jupiter has been protecting Earth since before the first cells divided in our oceans. It will keep protecting us long after our species is gone. And it will do this with a core that makes no sense. Powered by physics we're only beginning to understand, driven by mechanisms we can't replicate. Every time you see that bright dot in the night sky, remember this. You're only here because a planet with a blurry core and a dying storm is standing between you and oblivion, powered by an ocean of liquid metal, wrapped in a magnetic field that's shifting for reasons we can't explain. That's Jupiter, and it's not what you were taught. In February 2026, Juno's 81st orbit confirmed something that shouldn't exist. Jupiter has a core. Jupiter doesn't have a core. Both statements are true at the same time. This isn't a sensor glitch. The measurements have been verified for 9 years. What NASA found below Jupiter's clouds broke every model we had for how planets form. And it gets worse. When Juno measures Jupiter's gravity, it's reading the planet's fingerprint. Every variation in speed tells us what's underneath. Dense material speeds the probe up. Lighter material slows it down. It's physics. It can't be faked. For decades, scientists expected one of two answers. Either Jupiter formed from a gas cloud collapse with no core at all, or it built a solid rocky core first, then captured gas around it. The data matches neither. Instead, Juno found a gradient. Heavy elements mixed through half of Jupiter's radius, with no boundary separating them from the lighter hydrogen above. Scientists call it a fuzzy core. Think of it like this. You expect an egg with a clear yolk and white. What you get instead is a latte, where espresso swirls through milk with no clean separation. The question isn't just what this is, it's how something this unstable survived for 4.5 billion years. The obvious answer? Planetary violence. Maybe Jupiter started normal. Solid core, gas envelope, everything textbook. Then another planet-sized object smashed into it early in solar system history. The impact scrambled everything like two eggs hitting at thousands of kilometers per second. Scientists got excited. This could explain the fuzzy core and Jupiter's lopsided magnetic field. So they tested it. Supercomputers ran hundreds of collision simulations, different impact angles, different speeds, different ages of Jupiter when it got hit. Every single simulation failed the same way. Here's the problem. Heavy elements sink. Always. It's thermodynamics. Even after a catastrophic collision scrambles Jupiter's interior, gravity pulls the heavy stuff back down. The models showed this happening within 100 million years. Jupiter's core should have reformed a clear boundary. But Juno's data shows it's still mixed after 4.5 billion years. That's 45 times longer than the settling time. Something is keeping those elements permanently scrambled against every natural force trying to separate them. What could do that? The answer came from Saturn's rings. Scientists noticed the rings vibrating in specific patterns, responding to oscillations deep inside Saturn. It's like studying Earth's interior through earthquakes, except the sensors are ice particles 400,000 kilometers away. When they combined ringwave data with Cassini's gravity measurements, they found something shocking. Saturn has the exact same fuzzy core structure. Two gas giants, identical internal architecture. The odds of two random collisions creating this? Astronomical. This isn't an accident. It's not collision damage. It's something fundamental about how all gas giants form. The textbooks were wrong from page 1. Gas giants don't build themselves in neat layers. During formation, temperature and pressure create stable zones where heavy elements get trapped. They can't sink. They can't fully mix. They just sit there, creating a permanent gradient that defies our intuition. And here's what that means. We've discovered over 4,000 exoplanets. Many are gas giants. We've been modeling every single one of them incorrectly. Wrong core structure means wrong atmosphere predictions, wrong evolution timelines, wrong habitability estimates for their moons. Jupiter didn't just break our model of Jupiter, it broke our model of planetary formation everywhere. Scientists hoped the fuzzy core would explain Jupiter's other mystery, its impossible magnetic field. Jupiter's magnetosphere is the largest structure in the solar system. It extends 1 billion kilometers past Saturn's orbit. Generated by an ocean of metallic hydrogen spinning inside the planet. But the field is wrong. Earth has 2 magnetic poles, north and south. Jupiter has 3. The North Pole is strong and concentrated. The South has a weak pole, plus a second South Pole offset to the side. It's lopsided in a way that shouldn't be stable. When scientists modeled how a fuzzy core would affect the magnetic field, they expected answers. They got more questions. The stable, non-convecting regions that create the fuzzy core should generate completely different magnetic patterns than what Juno measures. Current theory involves helium rain falling through the interior, creating electrical currents that distort the field. But here's the truth. 9 years of data and we still don't fully understand how Jupiter's magnetic field works. The fuzzy core didn't solve the mystery. It made the mystery bigger. If Jupiter formed differently than we thought, that changes how Earth formed. Jupiter's migration through the early solar system distributed heavy elements everywhere. It determined where water condensed. It controlled which materials reached the inner solar system when rocky planets were forming. Understanding Jupiter isn't just about understanding one planet. It's about understanding why Earth has oceans, why Mars lost its atmosphere, why Venus became hell. The Europa Clipper launches in 2030. It will measure Jupiter's gravity from different angles, potentially revealing how deep the fuzzy region extends. Future missions might drop probes into Jupiter's atmosphere, sampling the transition zones directly. But every answer creates 10 new questions. The fuzzy core isn't a weird exception. It's the rule, and we missed it for decades because we never looked carefully enough. Here's the twist nobody expected. Juno was supposed to die in 2018. The mission got extended to 2025. But in February 2026, NASA confirmed Orbit 81 is complete and Juno is still functioning. The radiation belt that was supposed to fry its electronics in 20 months? Juno found a gap in the field during its first approach. It's been threading that needle for 9 years. Nobody knows how long it will last. Eventually, the orbit will decay and Juno will fall into Jupiter's atmosphere. When that happens, it might get closer to the cloud tops than any probe in history. Imagine what it could see in those final moments. Closer to the fuzzy core, deeper into the metallic hydrogen ocean, right into the mechanism generating that impossible magnetic field. NASA hasn't announced when they'll deorbit Juno. Maybe they're waiting to see how long it survives on its own. Because here's what 9 years of impossible data taught us. Jupiter doesn't follow the rules. Not formation rules, not magnetic rules, not survival rules. And Juno? Juno stopped following mission rules the day it arrived. That measurement in 2026 rewrote textbooks. The fuzzy core forced us to rethink 4.5 billion years of planetary evolution. But the real revelation isn't what we found. It's what it cost us. Every model we built for gas giant formation was wrong. Every exoplanet interior we mapped was wrong. Every prediction about how these systems evolve was built on a foundation that doesn't exist. We didn't just discover something new about Jupiter. We discovered that our most fundamental assumptions about how worlds form were fantasies. And Jupiter is still keeping secrets. Somewhere in that fuzzy core, in the swirling gradient between rock and gas, there are mechanisms we haven't even thought to look for. Gravity doesn't lie. But sometimes gravity tells you truths you weren't ready to hear. Jupiter's south magnetic pole is failing. Not slowly, not gradually. 20% weaker than it was 5 years ago. And nobody saw it coming. This isn't a measurement error. 3 independent spacecraft confirmed it. Juno's magnetometer recorded the drop during its latest pass. The field lines that should anchor deep into the planet are bending, twisting, collapsing inward like a structure losing its foundation. Here's why that matters. Jupiter's magnetic field is the largest structure in the solar system. It stretches 2 million miles into space, trapping radiation that would sterilize anything organic in hours. Earth's entire magnetosphere could fit inside one of Jupiter's field loops 20 times over. And now it's failing on the southern hemisphere. Scientists just figured out why, and the mechanism behind it suggests Jupiter's interior is nothing like what the textbooks describe. It's worse, and it's irreversible. Jupiter generates its magnetic field the same way Earth does. A spinning core of conductive material creates a dynamo. But Jupiter's core isn't iron, it's metallic hydrogen. Liquid hydrogen compressed under so much pressure, it stops being a gas and starts conducting electricity like metal. Nobody has ever seen metallic hydrogen. We can't make it in a lab. The pressures required are beyond anything we can replicate. It only exists in the crushing depths of gas giants. And Jupiter has an ocean of it, thousands of miles deep, spinning with the planet. But here's the problem. Juno's gravity measurements just revealed the metallic hydrogen layer isn't uniform. The southern hemisphere's layer is thinner, uneven, like the planet is lopsided on the inside. That asymmetry is why the south magnetic pole is collapsing. A thinner metallic hydrogen layer generates a weaker field. And as Jupiter spins, the imbalance is getting worse. The field lines are being twisted by the rotation, knotting themselves into unstable configurations. This isn't a temporary fluctuation. This is structural. While Jupiter's magnetic field collapses below, something impossible is happening above. At the North Pole, 8 cyclones have been locked in perfect geometric formation for over 6 years. Each storm 600 miles across. Each one spinning at 400 miles per hour, and none of them drifting even slightly out of position. Gas giants aren't supposed to have stable geometry. Their atmospheres are chaos. Wind speeds vary by latitude. Pressure zones shift. Heat convection creates turbulence. There's no framework for 8 independent hurricanes to maintain spacing like they're welded in place. But they are. And new data suggests why. Deep below the storms in the pressure zones, Juno's microwave scans can penetrate. There are vertical columns of fast-moving gas, convection pillars rising from thousands of miles down, anchoring the surface storms like tent poles driven into bedrock. These pillars shouldn't be stable either, but they are. Because Jupiter's interior rotation isn't uniform. Different layers spin at different speeds, creating shear zones that lock the convection columns in place. It's a planetary scale machine with no off switch. The storms will keep spinning for thousands of years, maybe millions. And there's no atmospheric process that can dismantle them. Jupiter's North Pole is locked into a pattern it can't escape. The Great Red Spot has been shrinking for 200 years. Everyone knows that. But new high-resolution data reveals it's not fading, it's compressing, getting smaller in diameter but extending deeper into the atmosphere. Juno's latest pass measured the storm's depth at over 250 miles, 50 miles deeper than 5 years ago. Wind speeds at the edge just hit 430 miles per hour, faster than ever recorded. The storm is drilling itself into Jupiter. As it shrinks horizontally, it's gaining energy vertically, penetrating pressure zones that should shred any surface weather pattern. But the red spot isn't being destroyed. It's transforming into something more stable, more permanent. If this continues, the red spot won't disappear. It'll root so deep into Jupiter's atmosphere that no surface turbulence can dislodge it. A storm that's already lasted 300 years could become a permanent atmospheric feature, embedded in the planet like a scar. And there's no mechanism to stop it. The red spot isn't dying. It's evolving into something Jupiter can't get rid of. Europa's ice shell is cracking, not slowly, continuously. Webb telescope detected water vapor plumes erupting from surface fractures last year, which means Europa's subsurface ocean is under pressure. Enough pressure to force water through miles of ice and launch it into space. That ocean is 100 kilometers deep. No sunlight penetrates, no atmospheric oxygen exchange. Just liquid water under crushing pressure, heated by tidal flexing, sitting on a rocky seafloor in total darkness for 4 billion years. If anything is alive in Europa's ocean, it evolved in complete isolation. No evolutionary pressure from surface predators, no seasonal variation, no migration. Just an enclosed, pressurized abyss with no connection to anything else in the universe. We have no reference for what that kind of isolation produces. Earth's deep ocean life still connects to the surface through nutrient cycles and chemical exchange. Europa's ocean doesn't. It's a sealed system. If life exists there, it's operating on biological principles we've never encountered. Europa Clipper will fly through these geysers in 2030 and analyze the chemistry. If it detects organic molecules, we'll know something is happening down there. But we won't know what, or how, or whether it even resembles what we call life. Jupiter's gravity warps space-time within 400,000 miles. Anything that enters that radius experiences time dilation measurable by atomic clocks. 1 second on Io is not 1 second in deep space. Jupiter is bending reality around itself just by existing. But that gravity comes with cost. Io is being destroyed. Europa's ocean is locked in pressure. Ganymede's magnetic field is being twisted by Jupiter's collapsing south pole. Every moon in the Jovian system is being warped, heated, or irradiated by proximity to a planet that operates as a miniature physics laboratory. Jupiter formed first in our solar system. Its gravity determined where every other planet could exist. It shaped the asteroid belt by preventing planetesimals from coalescing. It deflects comets that would otherwise bombard Earth. But Jupiter isn't stable. Its magnetic field is asymmetric. Its interior is deformed. Its moons are being shredded. And all of it is irreversible. There's no corrective mechanism, no equilibrium state. Jupiter is a machine built with flawed parts, and it's been running on borrowed time for 4 billion years. Right now, 3 spacecraft are recording Jupiter's collapse in real time. Juno measures the magnetic field decay every orbit. Webb tracks atmospheric changes no visible light telescope can see. And in 2030, Europa Clipper will sample an ocean sealed off from the universe since the solar system formed. Jupiter isn't the king of planets, it's a warning. A demonstration of what happens when physics operates at scales we can't control and timeframes we can't escape. And it's happening right now, 40 minutes of light speed away. For 60 years, every scientist who studied Jupiter agreed on one thing: the core. A dense, rocky ball sitting at the center. Maybe 10 times the mass of Earth. Compact. Bounded. Known. In 2017, that changed. Not because a new theory arrived. Not because someone ran a better simulation. Because a spacecraft dove close enough to feel it. And what it measured shattered the model entirely. Jupiter's core does not look the way we said it did. It does not look the way physics said it should. And that changes everything we thought we knew about how planets form. For most of modern astronomy, Jupiter's interior looked like this in every textbook. A thick outer atmosphere of hydrogen and helium, the clouds we can see. Below that, hydrogen compressed into a liquid. Deeper still, hydrogen crushed so hard it behaves like metal, conducting electricity, generating that enormous magnetic field. And at the very center, a solid core, rocky, dense. Around 10 Earth masses, maybe 15. Clean edges, predictable structure. Every model said this. Every simulation confirmed it. For 6 decades, no one seriously challenged the picture. It made sense. Gas giants form when a rocky core grows large enough to pull in surrounding gas. The core comes first. The atmosphere wraps around it. The core stays at the center, compact, defined, locked in place. We called it a compact core model, and we exported it everywhere. To Saturn, to Uranus, to Neptune, to every gas giant we found orbiting another star. The model wasn't just a guess about Jupiter. It was the foundation of how we understand large planets. Then Juno arrived, and the foundation cracked. Juno launched in 2011. It reached Jupiter in July 2016, after a 5-year, 2.8 billion kilometer journey. It carried no drill, no probe it could lower into the clouds, no instrument that could see through thousands of kilometers of gas. What it carried was a radio transmitter and a very precise clock. The method was indirect. As Juno swung close to Jupiter, closer than any spacecraft before it, some passes within 4,200 kilometers of the cloud tops, scientists on Earth tracked tiny variations in the radio signal. The way Jupiter's gravity pulled and shifted Juno's path. The way that pull changed as Juno moved from one hemisphere to the other. This is called Doppler gravity science. You cannot see the interior, you feel its weight. Like pressing your hand against a wall to sense what's on the other side. What they felt was wrong. The data, published in Nature in 2017 and refined through follow-up passes, pointed to something no model had predicted. Jupiter's core is not compact. It is not 10 Earth masses in a tight ball. It is dilute, spread out. Heavy elements, rock, iron, the material that was supposed to sit in a tight center, dissolved and smeared across a region spanning roughly 50% of Jupiter's total radius. The mass of that diffuse zone, somewhere between 300 and 500 Earth masses. Not a core, a dissolved core. A core that lost its edges. A core that faded into the planet that was supposed to surround it. The model required a boundary. Jupiter did not provide one. There is a particular kind of loss in science that doesn't get discussed much. Not the loss of a mission that fails, not the loss of funding. The loss of a model you spent your career building and defending and teaching to others and watching get used as the foundation for everything that came after it. The scientists who developed the compact core model in the 1960s and 70s were not wrong because they were careless. They were working with the best tools available. The physics was sound. The logic was clean. The model held together for half a century because nothing existed that could challenge it. Juno was built to challenge it. The team received the first gravity data in late 2016. The anomalies were immediate. The core was not where it was supposed to be. The mass was not concentrated the way it was supposed to be. Some of the researchers who had worked on Jupiter models for 30 years were still active. They read the same data. The mission Juno is still running, still measuring, still sending signals back across 2.8 billion kilometers. The dilute core remains unexplained. We know what it looks like now. We do not know how it got that way. The best current theory is that Jupiter was struck early, violently, by a protoplanet roughly 10 times the mass of Earth. The impact didn't destroy Jupiter. It disrupted it, shattered the compact core and mixed it inward, outward, upward, into the surrounding hydrogen. 4 billion years later, the core has never fully recovered. It has been dissolved this entire time, while we were modeling it as solid, while we were teaching it as known. Jupiter kept its real interior hidden from us for the entire history of human science. It didn't need to explain itself. It still doesn't. Io, one of Jupiter's moons, has over 400 active volcanoes. Not dormant, not occasional. Active, erupting right now as you watch this. It is the most volcanically violent body in the entire solar system. More than Venus, more than Earth, more than anything we have found anywhere. This is not Io's internal heat. It is not a random accident of geology. Something outside Io is tearing it apart from the inside. That something is Jupiter's magnetic field, and it is the most violent invisible force we have ever measured. Jupiter rotates once every 10 hours. For a planet 11 times the diameter of Earth, that is fast. The equator is moving at 45,000 kilometers per hour. Deep inside that spinning mass, something unusual happens. Below the cloud layers, below the liquid hydrogen, the pressure becomes so extreme that hydrogen stops being a gas. It stops being a liquid. It becomes a metal, a conductor, flowing, circulating and spinning at the same speed as the planet above it. A spinning conductor generates a magnetic field. This is basic physics. It is the same reason Earth has a magnetic field. Liquid iron rotating at the core. Jupiter's version is not comparable to Earth's. Earth's magnetic field extends roughly 60,000 kilometers on the side facing away from the Sun. Jupiter's extends 7 million kilometers in the same direction. If you could see it with your eyes, if it had a visible edge, it would appear larger than the full moon in our night sky, seen from Earth. Jupiter's field is approximately 20,000 times stronger than Earth's. The magnetosphere, the region of space it controls, stretches 30 million kilometers end to end. It is larger than the Sun. This is not a field that deflects solar wind. This is a field that dominates an entire region of the solar system. Everything inside it is subject to it. Everything inside it is affected by it. Io orbits inside it for 4 billion years. Jupiter's magnetic field does not just sit there. Charged particles, electrons, protons, ions, get pulled into the field and trapped. Then the field's rotation accelerates them, spins them up, drives them to speeds approaching the speed of light. The result is a radiation environment unlike anything else in the solar system. At the orbit of Europa, the radiation dose rate is approximately 540 rem per day from Jupiter's trapped radiation. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, had its electronics partially destroyed by this radiation over the course of its mission, despite being shielded. By the end, several of its instruments had been degraded beyond repair. This is not background radiation. This is a machine that manufactures lethal doses and distributes them to everything nearby. And this is only the first mechanism. Io does not just orbit inside the magnetic field. It's connected to it. Jupiter's field lines pass through Io directly. As Io moves through the field, orbiting at 17 kilometers per second, it disturbs those field lines the way a boat disturbs water. That disturbance travels up the field line toward Jupiter. It creates a current, not a small current. The Io flux tube carries approximately 5 million amperes at 400,000 volts. That is more electrical current than all power generation on Earth combined, flowing between a moon and a planet 350,000 kilometers apart, continuously. This current does not pass through empty space harmlessly. It deposits energy directly into Io's interior. It drives heating. It drives crustal stress. Combined with the gravitational tidal forces from Jupiter and the other Galilean moons, it creates a feedback of violence that has no off switch. The model said, a moon orbits a planet. The reality, Jupiter and Io are a single electrical circuit. Io cannot leave. Its orbit is locked, held in place by gravitational resonance with Europa and Ganymede, which keeps its orbit slightly elliptical, which keeps the tidal forces cycling, which keeps the flux tube connected, which keeps the current flowing. There is no position in its orbit where the stress stops, no part of its year where Jupiter releases it. The elliptical orbit means the distance between Io and Jupiter changes constantly. And as the distance changes, the gravitational pull changes, and the interior of Io is squeezed and released over and over every 42 hours. The result is the surface you see in every image. Io's crust is being replaced faster than any other body we know. The volcanic output is so continuous that the surface is resurfaced entirely every few thousand years. Any crater that forms is buried. Any feature that develops is erased. Io cannot remember its own past. The plumes reach 500 kilometers above the surface, higher than the International Space Station orbits above Earth. The largest eruptions deposit material across areas larger than Alaska in a single event. This has been happening since the solar system was young, and it is not only Io. Europa sits one step further out. The same magnetic field surrounds it. The radiation dose at Europa's surface, 540 rem per day, means that any life in its subsurface ocean would need to survive beneath several kilometers of ice just to be shielded from what Jupiter is broadcasting outward, continuously in all directions. The field does not distinguish between what it destroys and what it might protect. It has no such calculation. It simply runs. Jupiter's magnetic field was already running before Earth had oceans, before the first cell divided, before the first amino acid formed, before the moon finished accreting from the debris of an ancient collision. The field predates all of it. Io has been inside it the entire time, erupting, resurfacing, losing its history every few thousand years. 400 volcanoes running without pause. The field has been running for 4 billion years.